Hello and welcome to E233. I'm your instructor, Gregory Myers. This video, we're going to take a look at another example as part of our fundamentals demo series. In this case, what we're going to do is we're going to build an interactive function that collects some information from the user and then prints it out into a nice fancy output. Basically, what we're going to do is do a quick scanf and printf demo. So the first thing that you want to do is either take a second to write this code or obtain a copy of this interactive_01 snip that I have provided. You want to go ahead and make sure that you include the function prototype in the growing list of our function prototypes. It doesn't really matter exactly where you put it in the list. In this case, what I'm going to do is I'm just going to add it before the help. I kind of want to keep help identify help a little bit, I guess you could say separate, just for ease of recognizing that we have a help function. But then what we want to do is we want to go ahead and copy the body of the function and then put that once again somewhere near the bottom of our ever-growing code file here. All right, so the first thing you want to note is with our interactive_01 that it accepts no input arguments and returns no output arguments. In other words, everything that we're planning on doing in this example is going to be self-contained in this particular function. And so all we want to do really is we want to collect some basic information from the user and then print that information out in a nice format. Now, I've went through the trouble of going ahead and setting up some variables for us to use. We have not yet covered strings or character vectors, and so there is going to be a couple of assumptions made here. The only thing that I briefly want to mention is that with a string, whenever you're allocating the size of a string, you want to make sure to allocate a size one larger than the largest piece of information that you attempt or want to attempt to capture. So in other words, if I'm anticipating someone with a last name or a first name with 9 characters in it, then I need to create a string that is actually 10 characters. And that is because of the string termination character that we'll see later on. Likewise, with the course department, I've created a character vector that we're planning on storing a string in. Since I've allocated 3 characters to the course department, that means the largest largest actual course that I can capture is actually course department I can capture is actually only going to be 2 characters. So just keep that in mind for right now. Basically, the number that you see in brackets, you can only capture data or number of characters 1 less than that number. And then, of course, the last variable that I have here is just simply an integer, a course number. So the first thing we want to do is we want to create a series of printf and scanf calls that print to the console some information, some instructions for the user, and then a scanf that's going to then capture the information. So the first thing we'd like to do is a printf that simply says, please enter your first name. Now, you can either choose to use the same nomenclature as your variables, or you can simply make it a little fancier, make it a little more human readable. Either's fine, doesn't really matter to me. Sometimes out of convenience or consistency's sake, I just simply make it match the variables. Does not matter. It's basically aesthetics to the user. We want to follow this up then with a scanf. And what we want to do now is we want to use a different format spec identifier than what we've done in the past. In this case, it's going to be a %f. And then the second parameter for the scanf is the variable in which we want to store the value in. In this case, we want to use the address of our first name variable. From here, it's pretty straightforward. We simply add another printf with another pleasant prompt to the user that says, please enter your last name. And once again, I follow it with a colon and a new line. That's just an aesthetic preference on my part. And then a scanf with another %s. And in this case, then it's going to be the address of a last name. Sorry about that, hit the wrong key there. It's supposed to be a semicolon. And then the third one is printf. Please enter a course department. Followed by the new line, and then a scanf with a %s, and then ampersand course department, and then printf, please enter a course number. Once again, minor typo there, scanf, and then scanf. And this time, though, since it's a integer, we're going to do a %d, and then ampersand course number. Now, little comment that we might want to consider doing is, since we are relatively restricted in the lengths of our strings, we probably ought to make mention of that in the prompt. So maybe something like no more than 9 characters, however you wish to convey that information. And then also in the course department, no more than 2 characters. We're going to have plenty of opportunity to play around with strings. So for right now, this is a reasonable limitation. The main thing, or the main purpose with this demo, is to show us how to use the printfs and the scanfs to communicate prompts to the user, collect information, and then ultimately print the information out in a nice format. And in this case, what I'd like to do is just print a welcome message to the user. So printf, hello, %s, %s, with an exclamation point, always like to be friendly. Welcome to %s, %d, followed by a new line. Now, that probably looks like, quite frankly, a little bit of nonsense. So what we want to do is we want to focus on those %s's and that %d. So they are placeholders for information or data or variables or values, whichever way you want to think of it, that we want to then put into this templated string. So in this case, then the hello %s, %s would probably be our first name, followed by our last name. And then the next one, the welcome to %s, %d, notice I intentionally left out the space here, would be then for the course department, followed by the course number. Now, let's go ahead and save this. Let's go ahead and build it, and at least check to see if we have C code that compiles. Now, keep in mind, our code will not yet run. Why is that? Well, because we have the prototype, we have the function written, but we've never actually called it. And I address how to call these functions, especially in this more complicated fundamentals demo that we have now built, by using these command line switches. So if you come up here to main, I have addressed in an earlier video how to set this up, this if statement. We just simply want to add another if statement, another else if. So else if, and we're going to use our string compare I. We're going to look at our argv square brackets 1, which is going to be the first argument after the name of the executable. And we want to see, does the user want to run our, in this case, our interactive _01. Do they want to run that particular demo? And if there are v square brackets 1 or the argument that they type in after the executable matches interactive _01 with a slash in front of it, then yes, the user did in fact want to run our interactive 01 demo. And we simply put a comment here, call to the first interactive demo. All right, so go ahead and save it. Go ahead and build it. Good, we've got a successfully built code. Now we're ready to run it from the command line. So what you want to do is you want to go open the command line, and you once again want to cd to the location where you have your projects. In this case, it's documents, courses, EE 233. I'm keeping it in a projects folder. I'm calling that project fundamentals demo. And remember, at that point, then we should be looking for the distribution folder, debug, min.gw, and there is our fundamentals demo.exe. So at this point, then, go ahead and run it. If we did not provide any command line switches, we'll get the help. This is also a gentle reminder that we need to update the help. So we probably ought to take just a second to go ahead and do that. In this case, what I'm going to do is I'm going to add my extra switch here. I'm going to come down and put in the fundamentals _demo.exe, and then the switch. And then once again, a little bit of information here. You can always improve on this. And this just simply calls the interactive _01. Not the most informative help, but it's meant more of a process and a placeholder for you to think about it in the future, what you want to put there. All right, so you go ahead and build it. And we'll rerun the fundamentals demo. There is now the hint to the user that they should be adding some sort of switch. In this case, we're going to rerun the fundamentals demo, this time with our interactive _01. You'll see that we have, in fact, processed some input arguments from into main. In other words, our command line arguments have been brought into main. And then we have now called our function. We can tell that we've called our function because you'll see now that we're being prompted to enter our first name. In this case, I'm going to put in my name, my last name, the course, EE, of course, department rather, EE, and then the course number, 233. You'll see that I have inadvertently missed a new line there. But we do have a nice message here that says, hello, Gregory Myers. Welcome to EE 233. Now, I'm going to fix my mistake here by just simply right-clicking on any of the any code, any of the places where I reference interactive _01, go to the function implementation itself, and you'll see, sure enough, yes, we forgot the new line. Build it once again and run it one last time. Gregory Myers, EE 233. And sure enough, there we go. We have nicely formatted output to the user. Now, you want to take this video in conjunction with the other videos, particularly on the formatting of integers and double data types. And you can see at this point, then we've got very little in the way of limitations as far as what you can print out to the user as far as making it look aesthetically pleasing. Also, probably in the back of your mind, you probably realized that this is how spam emails get created, essentially using a process similar to this, where they're using placeholders to fill in your information maybe some personal information about you that's been collected from a website or from a mailing list or so on, and then having what looks like a customized email to you, but instead it's still nothing but spam. So hopefully you found this video useful. As always, if you've got any questions or comments, don't hesitate to email me, and thank you for watching.